Good morning students, myself Shekhar Gowda. Today we will discuss numericals based on whatever I taught in last week, and I will do the revision. Just 10 minutes, last 10 minutes I will revise this whole topic, means whatever I taught from last 1 week, that what we will discuss. Right, now let me continue yesterday topic. Yesterday we discussed photoelectric effect. Okay, so in last class we had discussion on photoelectric effect. So right, in this photoelectric effect, so one word is important, that is stopping potential. What is stopping potential? Do you know what is stopping potential? Kushi, what is stopping potential? Stopping potential. Stopping potential. Potential. So what is stopping potential? Right, especially this word mainly we will use in photoelectric effect only. Right, here when there will be ejection of electron, after ejection of electron, normally electron will move from cathode to anode side. Okay, so from the cathode metal surface electrons will be released, later they will move towards the anode side, the resultant we are getting current. That what we had discussion in photoelectric effect. So here what is the stopping potential? Right, in photoelectric effect we know that this is what metal, that what cathode metal electrode. Okay, metal electrode, on this we will be having electrons. Right, this is what cathode metal electrode. Okay, cathode, on the cathode surface we have metal coating. This is what the metal coating. Metal coating we have, this is what the metal coating. On the, in the metal coating, in the valence shell there are valence electrons. Right, now what we are doing here, when we pass the light, this is what light, sunlight or any radiation, when we pass light, then there will be an ejection of electron. Here electron ejection will take place. Ejection of electron will take place. Right, here what is stopping potential? How you can define stopping potential? Means the amount of potential which is required to stop the ejection of electron. The potential which is required to stop the ejection of electron, means externally if you give the potential to stop ejection of electron, then that is said to be what? Stopping potential. So that means we are applying the potential. Potential is one kind of force. Okay, so from the external battery only we are applying. Then when we apply this external potential, this potential must be equal to its kinetic energy, no? Yes or no? So this stopping potential will be exactly equal to kinetic energy. Then only you can stop the motion of electron. Then only you can stop the motion of electron. Here stopping potential is nothing but the potential required to stop the ejection of electron, means to stop the kinetic energy of electron or ejection of electron. Here you can do the ejection but not kinetic energy. Okay, but not kinetic energy. So here stopping potential will be equals to kinetic energy of electron. So right, this point you need to remember here. So stopping potential, this what is equal to stopping potential. Stopping potential. Stopping potential. Stopping potential is equals to kinetic energy of electron. So whatever the potential we are giving is, which is equal to exactly kinetic energy, then you can stop the electron. No? That is what? Stopping potential. So please remember here, kinetic energy which is equals to what, amma? Of mv square. Here m is the mass of electron, v is the velocity of electron. This potential normally you can take it in electron volts or volts. Okay, electron volts or volts you can take it. Okay, this stopping potential unit will be electron volts or volt. Then this stopping potential is exactly equal to kinetic energy of electron. So here just ejection will take, means you can remove electron from the nuclear attraction but no kinetic energy. Why? Because you are opposing the motion of electron, means the flow of electron. Then what you have to do it, you have to apply the some potential. That whatever the potential, it must be equal to kinetic energy. Then only you can stop the electron inside the circuit. Okay, this is what stopping potential you have to remember. Right. Let me revise topic whatever I taught in the last class. In the structure of atom, from the starting, in the starting we discussed some experiments for the discovery of fundamental particles like electrons, protons, neutrons and nucleus. Okay, electrons will be discovered from the cathode ray experiment, and same way protons, positive charge particles, will be discovered by repeating the same experiment. Okay, next neutrons, when high speed alpha ray bombarded with beryllium sheet, then so we got what one kind of neutral particles, their name is neutrons. They are having equal mass of protons. And next after discovery of electron and proton, so J.J. Thomson proposed one molecular, means atomic model. According to J.J. Thomson, that what it's like a watermelon shape, that whatever atom, in that electron and proton will be like seeds are electrons, and reddish matter is like proton. That what given by the J.J. Thomson. After that discovery of protons and electrons and neutrons, then Rutherford discovered alpha ray experiment. So according to alpha ray experiment, in every atom there will be a nucleus. That nucleus will be deposited at the center of atom with high density. That what he discovered from the alpha ray scattering experiment. Then finally he concluded the volume of nucleus is 10 power 5 times smaller than volume of atom. Okay, volume of atom with respect to size also it will be same. Okay, the next after discovery of fundamental particles, then here J.J. Thomson model successfully explained electrical neutrality of the atoms, and Rutherford model successfully explained discovery of what nucleus and stability of what protons in the nucleus because of neutrons, and electrons will be outside the nucleus and they are revolving around nucleus like planetary model. This is what given by the Rutherford, and he did not explain that what how electrons are exactly getting stability when they are revolving around the nucleus. That what is not explained by the Rutherford model. That is what the drawback, right? So after discovery of electrons, protons, neutrons, and especially neutrons and protons, we have some fundamental species like isotopes, isobars, and isotones and isodiaphers. Okay, these are the some basic terms. What are isotopes? Isotopes means same atomic number, different mass number. Same atomic number, whatever the species which are having same atomic number differ with mass number are said to be isotopes. Example: hydrogen, deuterium, tritium, carbon 12, carbon 13, carbon 14, oxygen 16, oxygen 17, oxygen 18. Okay, like that. So we have the different kind of what isotopic species. Next, isobars. What are isobars? Which are the species having same atomic mass number differ with atomic number. Okay, same mass number but differ with atomic number are said to be isobars. So examples like you can take argon and calcium are having same atomic mass, different atomic number, and carbon 14 and nitrogen 14 also isobars. Next, isotones. What are isotones? Isotones are the species which are having same number of neutrons but they differ with a different mass number and a different atomic number. Okay, right, same number of neutrons they should have it, but their atomic masses and this what atomic numbers will be different. Example: carbon 12, carbon 13, if I have it, carbon 13 will be having what, how many neutrons? 7, 13 minus 6, 7, and same way nitrogen 14 also, 14 minus 7. So both are having same number of neutrons, but here their mass number and atomic numbers both are different. So like that, so these are all said to be isotones. Next, isodiaphers. What are isodiaphers? Which are the species having same isotopic number are said to be isodiaphers. So what is the meaning of isotopic number? Isotopic number you can calculate from what atomic mass minus 2 into atomic number. So this what A minus 2Z. For any species or for any element, A minus means any two elements, A minus 2Z value, if it is same, then those species are said to be isodiaphers. Okay, this is what we had discussion. So example, so you can take any example you can create. So isotopic number you have to get the same. Okay, right. Next, isoelectronic species. Here isoelectronic species are only differ with what means they are having the same number of electrons. Based on electrons only we are taking isoelectronic species. What are isoelectronic species? Which are the particles or ions having same number of electrons, different what atomic number and different mass number. You can take it. These are what only you can apply for ions. Okay, ions. So example like Na plus, Mg plus, Al plus 3, neon, F minus, O minus 2, N minus 3, carbon minus 4. These are all isoelectronic species. Okay, so right. So these are all means which are having the same number of electrons are said to be isoelectronic species. Next, isosters. So what are isosters? Did I give isosters? No? Kushi? Did I give isosters? Right. So isosters, they are, which are the particles means which are the molecules or which kind of species having same number of atoms with the same number of electrons. So example, carbon dioxide and N2O. These are said to be isosters. Okay, isosters means with the same number of atoms in the molecular formula, same number of atoms you have to get it and same number of electrons also you have to get it. Those kind of what species are said to be isosters. So this is what we had in last session. After this, and we have to understand Niels Bohr atomic model, we need to know the basic terms, basic that what basic you know that basic idea on electromagnetic radiation. So what is electromagnetic radiation? Electromagnetic radiation is what dual character. Okay, so it behaves like a particle nature as well as wave nature. So right, if you see the wave nature of that what electromagnetic radiation, so electromagnetic radiation is a one form of energy. Okay, it is available in the nature and from the stars we are getting electromagnetic radiation. From stars and from electric bulbs we are getting electromagnetic radiation. This electromagnetic radiation based on what its regions, based on the wavelength or wave number or frequency, it is divided into different regions and these regions are having different types like cosmic rays, gamma rays, X-rays, UV rays, visible rays, infrared rays, microwaves, radio waves. So like that you will be having the different kind of electromagnetic radiations. Okay, right. For this electromagnetic radiation, if you see the nature, there are two nature, particle nature and wave nature. So first let me explain wave nature. What is the wave nature? Wave means so any that water, any kind of water, any kind of thing, whenever it is having means whenever it is striking object, definitely it has to reflect or it has to, whenever it is passing, then definitely it has to get some interference and diffractions. So either reflection or interference or diffraction. These are the properties if it is having is said to be wave. Once it is having these properties, definitely it should have fundamental parameters like wavelength, wave number and frequency. Okay, so these are what we explain. Then what is here what wave number? So every wave means every electromagnetic radiation have some that what kind of wavelength. Then what is a wavelength? Wavelength means what? That interdistance between the two crests or two waves. Okay, that is said to be wavelength. Wavelength is inversely proportional to energy. So energy is more, wavelength will be more. So what are the units of energy? Wavelength? Centimeters, meters, angstroms, picometers, nanometers. So length, wherever you are finding the length means length, all units you can use for the wavelength also. Length is there, wavelength, length units. Okay, right. Next, wave number. What is the wave number? Number of waves present in 1 centimeter distance are said to be wave number of that what particular electromagnetic radiation. So what is the wave number? Wave number is equal to 1 by lambda. So 1 by lambda means 1 by wavelength. 1 by wavelength means 1 by centimeter means centimeter inverse, meter inverse, angstrom inverse. Okay, like that you will get the, so wave number units you will get it. Okay, wave number is directly proportional to energy. Next, frequency. If you take frequency, how you will define frequency? Number of cycles passed through a particular point in 1 second. Then cycles per second is the unit of frequency. 1 cycle per second is equal to hertz. So frequency units are, you can use cycles per second or per second. 1 cycle is there, no need to use per second also you can use for the unit of frequency. cycles per second or hertz. Both units you can use it. Okay, for frequency. So what is the definition of frequency? Number of cycles passed through a point in 1 second. That is said to be frequency of the electromagnetic radiation. The number of cycles are more in a 1 second. Passing number of cycles are more from the one electromagnetic radiation. For that electromagnetic radiation, energy will be more. So why? Because here energy equals to h nu. Nu equals to what? C by lambda. 1 by lambda equals to nu bar. So energy directly proportional to frequency and wave number and inversely proportional to wavelength. So this is what based on that. So you can get the numericals. You can solve the numericals. So this is what wave nature of electromagnetic radiation. Next one thing, whenever it is if you see the wave nature of that what any electromagnetic radiation, in that electromagnetic radiation there is electric field and magnetic field, and this electric and magnetic field are perpendicular to propagating direction of the wave. That what you need to understand. Based on that we have the diagram. Okay, right. Next after that, particle nature of the electromagnetic radiation. So this particle nature what proposed by mainly Max Planck. So according to Max Planck, so this electromagnetic radiation will be discontinuous, and this electromagnetic radiation will be in the form of what? Packets, small packets, that each packet is said to be what? Quanta or photon. So that photon is nothing but one packet. So here every light has what? N number of packets. These packets, this discontinuous means flow of these packets, we are getting the light. Okay, light means what? Electromagnetic radiation we are getting. This is what given by the Max Planck, and here one packet energy will be always fixed. That is what? Quanta. Quanta means what? Fixed amount of energy of the packet is said to be quanta. So one quanta means one packet energy. So this one packet energy you can calculate by using E equals to h nu. Same formula you can apply it. Okay, E equal to h nu. If I have n number of packets, then you can multiply with n. Then you will get what? N into h nu. You will get the energy of the n number of packets. If n number is equal to Avogadro number, then so that whatever the Avogadro number of particle means photons, Avogadro number of packets energy, or 1 mole of packets energy is equal to 1 Einstein. Right. This is what given by the Max Planck. Right. Now you need to explain that what how electromagnetic radiation is in particle nature. For that we have experimentally two things. One is black body radiation, other one is photoelectric effect. So these are the 2 points. From these two experimental observations you can say that yes, electromagnetic radiation nature is particle. Right. So black body radiation, first one, black body radiation. So how we can explain black body radiation? This is what the one black body. What is a black body? Black body is the ideal body. So what is a black body? How we will define? Which is the body can absorb complete radiation or can emit complete radiation is said to be black body. So let us assume here we have black body. Now what I am doing here, just I am passing means electromagnetic radiation. So by absorption of this electromagnetic radiation, definitely its temperature will increases. Its temperature will increases. That means whenever this electromagnetic radiation is striking on the surface of this black body object, so definitely, so being a one particle, whenever it is striking on that, definitely there will be friction. Friction means whenever it is particle nature, then only you will get the friction. So due to this friction, then temperature of this body is increasing indirectly. Means whenever one body is striking with other body, or one object is colliding with other object, definitely you will get the heat. Okay, this is what black body radiation, also one kind of particle nature only you can give the explanation. And one thing here, this what you can explain by taking any one of metal rod, just heat up, means by on heating of metal rod. So at different temperature, if you heat it, high temperature, whenever temperature is more, definitely after heating, then it will convert into one kind of red color. That metal will convert into red color. So after getting red color, definitely it will release the electromagnetic radiation. This electromagnetic radiation, that what wavelength is different with respect to temperature. If temperature is more, then wavelength will be less. And temperature is less, wavelength will be more. Why? Because temperature is directly proportional to energy. So energy inversely proportional to wavelength. So based on this, whenever temperature is increases, for example, there will be metal we are heating at 500 degrees Celsius. After heating 500 degrees Celsius, metal will absorb energy, and it will convert into one kind of color, that is red. Then it will release the energy. the electromagnetic radiation it will release. That wavelength you can find it at T1 temperature. And next again, if you heat it temperature at more temperature 700, then at 700 also it will release electromagnetic radiation. That the temperature is T2 and alpha is what? Lambda 2. Now if I ask question where lambda will be more at a low temperature, at high temperature lambda is less, at low temperature lambda will be more, then this whatever the shift is said to be what? Lambda shift. In physics point of view, we will discuss Wien's theory. Okay, so in physics also we will discuss, that is what shifting of lambda by Wien's theory you can discuss. Okay, but here we don't have that much information. Just what this black body radiation confirms there will be a particle nature. Right, after that we have photoelectric effect. So photoelectric effect means what? Here in that what we are getting what? Current from the radiation. We are getting that flow of electrons from the radiation. That whatever the effect is said to be photoelectric effect. Photo means light. By passing light, this light will be absorbed. Whenever this absorbed light energy is more than this nuclear attraction with electron, then definitely it will eject the electron. That whatever the excess electron which is converted into kinetic energy of the electron. Once electron in the motion inside the circuit, definitely it will flow and it will give the current. This whatever the effect is said to be photoelectric effect. This photoelectric effect only we are using in the solar cells. This mechanism only we are using the solar cells and solar roofs. Okay, solar roofs. Right, this getting current, photoelectric effect depends on what? Nuclear attraction. Nuclear attraction between what? Electron and nucleus. That attraction is said to be work function. If work function is more, then getting ejection of electron will be less. Which is the metal is having highest work function, then in that getting what? Photoelectron will be less, and getting current from that element also it take less, means why? You have to give the more energy. Okay, you have to give the more energy. So like that we have discussed with alkali metals, by taking alkali metal, lithium, sodium, potassium, okay, rubidium, cesium. So from cesium, so easily you will get the electron. From the cesium easily you can produce the current. So cesium, even in presence of candlelight also, it will eject the electron, it will emit its electron, it will lose its electron, by that you will get the current. Okay, so here lithium case, okay, a little difficult. Why? Because it is very close to the nuclear attraction, this valence electron. Okay, with work function you can explain. In NCERT one table will be given with the work function values. Okay, so you can read NCERT and you will get complete information. Okay, this is what we discussed in the last class. Right, next one stopping potential in the photoelectric effect. After passing the light, now electron will be ejected. Then this after ejection of electron, whatever the excess electron more than this work function, that energy will be converted into kinetic energy. Right now, what if I want to do? If I want to stop this electron motion, then what I have to do? I have to oppose this motion. No? To oppose this motion, I have to apply some potential. Whatever the potential I am applying to stop the electron, that potential is said to be stopping potential. This stopping potential must be kinetic energy of the electron. That stopping potential will be equals to what? Of me square. This is what you need to understand. Right now what you can take it here, if I want to stop, then we have, this is what the formula we have, that is what E equals to what? E naught plus, can I take here stopping potential EV? This is what the kinetic energy. So same thing you can take it here, kinetic energy is equal to stopping potential also you can take it. This is what, whatever kinetic energy is there. Now if I apply here stopping potential, then what I will get here? The stopping potential EV will be equals to E minus E naught. Okay. Also we can, this is what the mathematical relation between stopping potential and kinetic energy. Just what is the formula of kinetic energy only. Why? Because this is equal to kinetic energy. Okay, right. This is what we had discussion up to this. So you are going to write exam on Monday. Okay, up to this syllabus. Okay, right. Now we will work out some numericals based on these concepts. Okay, right. Right, we will work out NCERT problems. Right, please take your NCERT textbook. Right, especially what are the numerical areas mainly? What are the numerical areas? One is electromagnetic radiation, especially wave nature, okay, and the particle nature based on that, and next one is photoelectric effect. Okay, these are the only two areas, especially you can get numericals, mainly you can get numericals. Okay, right, now let me give, right, so now, all right, in NCERT we have in-text questions, and after the completion of topic also, book back also we have questions. Those questions also you can solve it. We have right. Right here, page number 65, question number, exercise question. So 2.7, 2.7. Now let me write question. Question is calculate the wavelength. Calculate the wavelength, calculate the wavelength, frequency, and wave number of light whose period is 2.0 into 10 power minus 10 seconds. Right here we have one word period. What is the meaning of period? Period means time period. Okay, period is what? Time period. So now here what they are asking here, we have that what one light we have, and whose period is what means indirectly time period will be given, that is what 2 into 10 power minus 10 seconds. And now we have to calculate wave number, wavelength and frequency. Right, so where we have the seconds unit, where we have second units per second. Frequency, right, so frequency units are what? Frequency is equal to what are the units of frequency? Frequency equals to cycles per second. Here without cycles, if I have it 1 by time also I can take, no? This is also one more formula, you can take it. Frequency formula is what? 1 by time period. 1 by time period, another formula also you will get it, or cycles per second, both are same only. Right now 1 by time, frequency equal to 1 by time. Now frequency nu is equals to 1 by t. So 1 by t equals to what? 1 by 2.0 into 10 power minus 10. What will you get, amma? 0.5 into 10 power 10 you will get, no? Which equals to 5 into 10 power 9 second inverse. Yes or no? Second inverse is what? Units of frequency. Right, now we have the frequency. I calculated what? Frequency. This is what I got. After getting the frequency, you can calculate wave number and wavelength, no? So wave number, what you can get? Wave number or wavelength. This is what the frequency. Wavelength is what? Lambda you have to calculate. How you will calculate lambda? Right, now E equals to h nu, which equals to h c by lambda. Yes or no? Right. Now here frequency, you know that. So after getting the frequency, then what you can write here? Right. Then what E equals to h nu, h with cancel. Then what I can write here? What I can write? Lambda equals to h with cancel. Then what I can write here? C by nu I can write, no? Then I will get lambda. Then C is the what? Light velocity. 3 into 10 power 8 upon nu is what? 5 into 10 power 9 we have. Then what will get here? What will get? Calculate lambda. What you are getting lambda? C by frequency. 5 by 10 and 3 into 10 power minus 10. Lambda what you are getting? In meters you will get it. In meters how much you will get, amma? Here you can take it. So 3, amma? 6 into 10 to the power of 6 into 10 to the power of minus 2 meters. This equals to 0.06 meters. Okay. So right, this is what the wavelength. After getting the wavelength, then wave number. So 1 by lambda. This is what the nu bar equals to what? 1 by lambda, which equals to 1 by what will get? 0.06. What will get, amma? What will get here? 100 by 6. 100 by 6 means 100 by 6. What will get? 100 by 6. Amma 16 point 16.6. Right, 16.6. This is what the wave number. Wave number means what? Meter inverse. This is in meters, this is meter inverse, and this is what? Second inverse. Okay, right. This is what the method to find wavelength, wave number, frequency. Here only that what time period is given. So time period is given means what? You need to know that frequency is inversely proportional to this what? Time period means frequency of any radiation is equal to 1 by t, time period. So here period means time period. Okay, right. This is also from the question, but this information is not given in NCERT. But if you solve the questions, book back NCERT questions, when you solve the NCERT book back questions, you will get lot of knowledge. Okay, no need to do any textbook. So NCERT, from the theory you will get some knowledge, and by doing what? In-text questions you will get some knowledge, and exemplar questions you will get knowledge, and by doing book back questions you will get extra knowledge. So together, so you will get perfect knowledge. No need to refer any textbook. Okay, NCERT is more than enough. Okay, right, next one more problem. We'll do one more problem. Right. So what is the number of photons of light? Next question. Let me write next question. Right, next question. Calculate what is the number of photons. Many times this question asked in previous JEE mains also. What is the number of photons? Next question. What is the number of photons? Number of photons. Photons. This same page number 65, and question number 2.8. Question number 2.8. These are all exercise questions. Okay. Right. What is the number of photons of light? Of light with a wavelength of with a wavelength of wavelength of 4000 picometers. 4000 picometer that provide 1 joules of energy. 1 joules of that provides 1 joules of energy. Right here, how you have to solve it, Kushi? How you will solve this question? Right here, what is the number of photons of light with a wavelength of 4000 picometers that provide 1 joule of energy? Okay, right. Now here, one of electromagnetic radiation ray will be given. Its wavelength is 4000. Here wavelength is given, then you can calculate. This is what the 1 photon energy. Right, answer is what? Here E equals to hc by lambda. Here h is the Planck constant 6.67 into 10 power minus 34 into light velocity 3 into 10 power 8 upon 4000 picometers. 1 picometer equals to how many? How many meters? Nanometers, that one. 10 power minus 9 nanometers. I asked picometers. Picometers. Right, into 10 power minus 12, you will get meters. So 1 picometer equals to 10 power minus 12 meters. Okay, right. Now if you simplify, what will you get, Amma? Here what will you get here? This equals to, if you simplify, what will you get here? Here 8, here 8. Then remaining is what? Minus 26, and here 12. 26 means remaining how much? Here what? Here 3 and here 3. What will you get here? 6.67 into 3 into 10 power minus 26 upon 4 into 10 power minus 9. This what? 9, if you take it numerator, then you will get 10 power minus plus 7 plus 9 you will get. So plus 9 and 26 get cancelled. Then what will you get here? Amma? 17 you will get. Right, here 17. 17. Right, now if you simplify, what will you get here? 20 by, nearly 20 you will get. 20 by 4 into 10 power minus 17. 4 ones are 4 5s are, which equals to 5 into 10 power minus 17 joules. Yes or no? So this is what 1 photon energy. But what they are saying here, 1 photon is this much. If I create 1 joule of energy, in that how many photons I need to take it? Then you have to do the crisscross. Okay, this is what 1 photon energy. This is what 1 photon energy. 1 photon energy. This is what we calculated. After calculating 1 photon energy, now 1 photon energy, 1 joules, in that there are how many photons? Do the crisscross, then you will get the answer. What will you get answer? What will you get, Amma? What will you get, Amma, answer? Right, here according to question, here 1 photon means 1 photon energy, we got 1 photon energy is equal to 5 into 10 power minus 17 joules, and if I have 1 joule, in that how many photons are there? This is question mark. Then after getting question mark, crisscross, do crisscross, then here x value will be equal to number of photons, then number of photons will be equals to 1 into 1 upon 5 into 10 power minus 17. Then what will get, Amma? This equals to 1 by 5 into 10 power 17. 17 means you can take it here. So 10 by 5 into 10 power 16 you can take it. Then here it will be equals to 2 into 10 power 16 photons. To create 1 joule of energy, you need to take how many photons? 2 into 10 power 16 photons you have to take it. Here in the question, this is what the wavelength of 1 photon will be given. 1 photon energy you have to calculate. So 1 photon energy equals to these many joules. In 1 joules, to get what 1 joule energy, how many photons required? Do the crisscross. One photon is this much. To get 1 joule, how many photons required? Do the crisscross, then you will get the answer. This is what number of photons, okay, required. So like this you can do the problems. Next, like this there are many problems. Let me do it one question, one problem on photoelectric effects. Right, one problem on photoelectric effect. So page number 40 and question number, problem number 2.9. Last one question, we will solve it. Copy it. If you solve all NCERT textbook questions, that is enough, more than enough to crack any kind of problem. Right, next last question. The threshold frequency that is what nu naught for a metal is 7.0 into 10 power 14 second inverse. This is what the frequency, second inverse, and calculate kinetic energy of an electron emitted when radiation frequency nu which equals to 1.0 into 10 power 15 second inverse hits the metal, then what they are asking here, you need to calculate kinetic energy, okay, kinetic energy of the photoelectron. In the photoelectric effect you have to calculate. So here there is a radiation, its frequency is what, if you see the solution, right now we have, this is what the metal, on the metal surface we have electron, valence electron. Right now we are passing what, radiation. Then this what radiation frequency will be given, which equals to 1.0 into 10 power 15 second inverse, and after that here this what, there will be ejection of electron. Then once it eject, it will get the kinetic energy. This kinetic energy you have to calculate, and here there will be a work function, that means what, there will be nuclear attraction. For this nu naught will be equals to how much, 7.0 into 10 power 14. Here threshold frequency means the minimum frequency required to eject the electron from the nuclear attraction of the metal. That is what the threshold frequency given, and this one is given, and they are asking kinetic energy. Then what will be the formula? Already you know that. So h nu is equals to what, amma? H nu naught plus kinetic energy, you know, E equals to E naught plus kinetic energy. Then kinetic energy will be equals to what, h nu minus h nu naught. Then you can take h common, nu minus nu naught. Then you put the values here. H is the Planck constant 6.6 and 10 power minus 34 into here. What you can write here? Nu value is what, how much? Nu value is what, 10 power 15. So 10 power 15, I will take it here 10. So 10 into 10 power 14 minus 7 into 10 power 14. You can take the 10 power 14 common, no? Right, if I take 10 power 14 common, then what I will get here? This equals to 6.6 into 10 power minus 34 into here. 10 minus 7 means you can write here. This is 3 into 10 power 14. 10 power 14 you can take it common. This is what the value you will get. If you simplify, you will get what, kinetic energy in joules. 6.6 into 3. What will you get value? Here 14 and 14. Okay. So minus 14 and plus 14 get cancelled. Remaining will be, so 20. Minus 20 is the remaining. And 6.6 into 3. Nearly you will get 20 into 10 power minus 20 joules you will get, which equals to 2 into, so 10 power minus 19 joules is the kinetic energy of the photoelectron. Okay, this is what the energy of photoelectron is, what 2 into 10 power minus 19 joules. This is based on the photoelectric effect, right? So in coming test, okay, in Monday test mostly you can expect this kind of problems. So whatever I taught concepts based on that, so please work out problems with formulas, okay, and right, so please work out all NCERT in text, exemplar and exercise questions. Once you complete NCERT, then mostly, so most of the materials you can solve it, okay. So without doing NCERT, don't do any other textbooks, okay. So please, firstly you have to complete NCERT only. After completion of NCERT, then you can practice any material, right? Okay. So right, next week I will continue this Niels Bohr atomic theory, okay. So next week we will discuss Niels Bohr atomic theory. So up to this we have test on Monday, okay. So thank you students, please work out all NCERT problems, okay. So thank you. Kushi, take your book.